All right, three transformations. Let's identify them. What does this negative do to the graph of that right there? What is the negative right in front of it do? Reflected about the x-axis. Yeah, like we've been doing this for like the whole last semester, so you should know this for sure. That one, reflected about the x-axis. We did this one. That's going to be a shift? Which one is it? Left, right, up, down? What is it? And if you just automatically know it's a left 4, because we did that one, left 4 units. Not even trying. And this one's going to be what? Down 1. So down 1. That's it. So we're not going to do a table. We're just going to do the one, then draw another one and the other one. So let's go from left to right. Do this, then do that, then do that. So let's do this one. Reflected about the x-axis. What does that mean? It means that you flip it. So therefore, this thing is going to be, let me use the same color. So this thing is going to go like this. Something like that. That's the first transformation. Then we're going to do a left 4 units. So I'm going to focus on this point, and I'm going to move it to the left 1, 2, 3, 4 units. And so it looks something like this. And then we're going to move it down 1 unit. Yeah, we're going to move it down 1 unit. So it's going to go, I'm going to focus on this one. Let's see here. Well, that's right. That has to be good. Okay. Let's see, how good is it? All right, how good is it? All right, whatever. It's close. All right, so it's here somewhere, so it's fine. It's a rough sketch. Okay, good. Yes, we're good. All right, let's move on. Exponential word problems. This is the lesson for today. Lesson 6C. Tell whether the function is an exponential growth function or is it an exponential decay function. Okay, so go ahead and copy that down. So like I said before, y equals a times b to the power of x is an exponential function where a is what? What is a? What does a represent? Anybody, what does the a represent in the equation? The initial amount. So this represents the initial amount. So the initial amount has nothing to do with if it's a growth or decay. It's just telling you that this is how much you have to begin with. What tells you if it's a growth or it's a decay is going to be the b value. This right here. This is going to tell you if it's a growth or if it's a decay. So it will be a decay if this b value is less than, not equal to 1, greater than, not equal to 0. So basically, it's not $1, and it's not having no money. It's having something greater than 0, less than $1. Is a half between 0 and $1. That's 50 cents, wouldn't it? So if it's between 0 and 1, it will be a decay. Anything greater, so it'll be a growth. It'll be a growth if b is greater than 1. Greater than 1. That would be a growth. So this initial amount has nothing to do with what it is, if it's going to be growth or decay. Just the b value. So in this situation, it will be a decay, because the b value is less than 1 and greater than 0. Okay, B. Who wants to answer this question? Not put anybody just on the spot. Is it a growth or is it decay? It's decay. Why is it decay? It's between 0 and 1, 95 cents. 95 cents is between 0 and 1. As simple as that. If you even think about money, and it just makes it so much easier. So it's going to be decay. All right? Daniel, is C going to be growth or is it going to be decay?
Growth.
Growth is correct, everybody. Yes, it is growth. Why is it growth? It's greater than 1. It's greater than 1. It's actually tripling, no? Tripling it. So it's growth. Sometimes they write it like this. D is equal to that right there. And so you're like, what is what? So maybe it should have parentheses around here. Maybe it should have this, like this. And then now you know what it is. The initial amount is 12,674. And it's going to be a growth or is it decay? What is it? Decay. The answer is decay. Decay because the b value is less than 1, greater than 0. Put parentheses around it if you want to. Is that growth or is that decay? It's growth. Yes, growth. Because it's growing by a little bit, but it's growing. Well, eventually it will grow. Any exponential grows eventually really big. So growth because the b value is greater than 1. All right, moving on. All right, here we go. So we're going to do actual word problems now. Okay, here we go. So you ask yourself sometimes, when am I ever going to use this? when am I ever going to use math? Why am I learning this? Maybe this will help you a little bit on how things work when things go down in value or go up in value. So problem number 2, a brand new car costs $31,000. The value of the car depreciates by 10% each year. So you want to know what is the value of the car after 8 years. So it's telling you that whenever it tells you that it's depreciating by 10% a year, it will be an exponential equation function or whatever that would model this. So you guys know what depreciates means, no? Depreciates means what? It loses value, no? So it will lose 10% each year. I mean, you could literally, you guys like that word, literally, do a 10%, take off 10%, take out 10%, and do it like that, no? Let's do it like that. You guys get a calculator? No, if you didn't get a calculator, don't get a calculator. That's a long way of doing it. I'm just thinking right now of doing it that way. But we could make a table. Why not? Let's do a table. I just thought about doing it like that. So what? So to begin with, this is 0. To begin with is 31,000. And then after 1 year, take off 10% of that. So what's 0.1? 10% is 0.1 of 31,000. 0.1 times 31,000. So it's going to lose 3,100 already. So it's going to be 31,000 minus 3,100. This is a dumb way of doing it. So it's already the value of it's 27,900, and then we're gonna get 10% of that. That's gonna lose. Let's go. I guess let's do it like this. 0.1 times 27,900. So it seems to be that it will lose that value. Okay, I already saw a pattern. So it's going to be 27,900 minus 2,790. So the value at year 2 will be 25,110. Year 3, the value will be 25,110 minus 2,500. And 10 and 11, 2,511. So this is going to be 22,599, and probably some of you guys will be doing it like that. And this is such a dumb way of doing it. I'm already getting fed up with doing it like this. 22,599 minus 2,200, 2,260. So at year 4, the value of the car is 20,339. Year 5, 20,339 minus 2,340, 2,304. 18,305. 6, 7, and 8. So we got 3 more to go. 18,305. 18,305 minus 1,831. 16,000, 16,700, 16,474. 474. Then 10% of that, 16,474 minus.
What's the number on number 5?
Here, 5? 18,305. 16,474 minus 1,640 minus 1,647. 14,827. And then 10% of that is, so I'm gonna go 14,827. 827, 14,827 minus 1483. 1483. 13,344. All right. So the value of the car is 13,344 after 8 years doing it. Where like you take a 10% every year, 10%, and then take it away. Makes so much sense, and it's dumb way to do it, but it's easy. I think to understand what's going on. But if you learn a little bit of math and not keep asking, when am I ever going to do this? When am I ever going to use this? Well, if you just try to learn this, it'll be so much easier to figure out that 13,344. So what I said is that it is exponential. Y is equal to a times b to the power of x. So now I know it's exponential, but it's decaying. So the value with respect to time, the value of the car with respect to time will equal to A. What's A? Anybody? What's A? The initial amount of that you paid for the car, which was 31,000. But the value of the car is going to go down. It's not going to keep 100% of its value. See, it's not 100% of its value. It's gonna lose how much? It's gonna lose 10% of its value. It's gonna lose 10% of its value per year. T for time. That's how we use this. So the B value is that it's 100% minus 10%. So the value of the car is going to equal to 31,000. What's 100% minus 10%? 90%. But I cannot use 90% to plug into the calculator. What is 90% as a decimal? 0.9. Because 90% means 90 per 100. That's the definition. 90%. So 90 divided by 100 is 0.9. So this is going to be 0.9, which is dk to the power of t. And now this is the formula. And now we can use it for v of what? How many years? 8 years equals 31,000.98 to the power of 8. Now you could just use a calculator. So we're going to do this first. I'm going to do this first and then multiply it by 31,000. So it's going to be 0.9 to the power of 8 times 31,000. What are you getting? What are you getting? The same number. Because it's much easier, faster. Let's say that this is your situation. Say you don't have a car, so you're going to go buy a car, 2,500, a used car that costs 2,500. The value of the car goes down by 15% a year. Find the exponential equation that models the situation. Find the value of the car after 5 years. Why don't you do that by yourself? So let's get down. Let's do it already. So it's saying it's right exponential model. So you're going to use y equals a times b to the power of x. So we're going to change the y to what? V of the value with respect to time. V of t, we'll plug it in later. V of t equals, what is a? 2,500. Okay, so now can we do this? What is it saying? That it will be what? Losing what? 15% of its value every year, no? So what is that going to be? 100% minus what? 15%? What's 100% minus 15%? 80.8. Oh, it's going to be 85%, which is going to be what? 0.85. There's the formula. And now we can use that formula to find the value after 5 years. And so you just gotta know how to put it in a calculator. So you, there's always that people make a mistake of doing this first, which is wrong. You gotta do the power first. 0.85 to the 5th power. So what's the value of the car after 5 years? What is it? 1,109? I got 1,109. Oh, we gotta have an answer. All right, it's 1,109. All right, let's finish off with this number 4. In 1980, the population of the city of Fresno was 220,000 people. From 1980 to 2019, the population grew at an average rate of about 2.4% per year. Write an exponential growth model given the population P of the city of Fresno. Then use that equation to estimate the population of the city of Fresno in the year 2019. So it's saying to write an exponential growth model. So we're going to use that y equals a times b to the power of x. We are going to change the y to what? What letter are we going to use? Change the y to what? P. Yes, right there it says population. Population with respect to time will equal to, what's A? 220,000. All right. What is B? I will give you extra credit if you can tell me what B is. Raise your hand. Who got it? What's B? Huh? What's B? And then put it in decimal form? No. Well, look. It's you're on the right track. You just don't can't put it in decimal. So look, so it's 100% as it is. It's growing. It's telling that it's growing. You're gonna add how much? 2.4%, no? So what's 100% plus 2.4%? 102.4%, no? Yes? So how do you get rid of that percent and make it as a decimal? Don't you get rid of that percent and move it to the left two? So it's going to be what? 1.024 to the power of t. That's the formula right here. Well, let me already plug it in, no? Let's plug it in here. So we're going to take out the t and we're going to plug in what? P of what? Oh, P of what? Actually, yeah. What are we plugging t? 39. Why is it 39? From 1980 to 2019, 1990, 2000, 2010, 39? 39? So this is going to be 39? So we're gonna get a calculator. 1.024 upon 39 times 220,000. And what are we getting? What are we getting? $554,000, about 554,000 something. All right, so there's the formula. You plug it in, 554,780. That's enough. We're not doing that.